Dear students, previous class we had discussed about the formation of wind energy. Now we are continuing this wind energy lesson. In previous class we had discussed about the wind energy, how to form the wind Coriolis force and wind turbine, different types of blades and different types of axis systems. Now today we are discuss working principle of the wind turbine. What is the principle of this wind turbine? The energy in the wind turns 2 or 3 blades around a rotor. The rotor is connected to the main shaft, which spins a generator to create electricity. Wind turbines convert the kinetic energy in the wind into mechanical power. So, wind energy in these wind turbines, there is a rotor and a shaft system. This is connected to generator. So, here the energy in the wind is a turns a rotor 3 blade or 2 blade rotor, and the rotor is connected to the main shaft, and this shaft is spins a generator, and this generator create electricity. That means wind energy is converted into electric energy, and wind turbines convert the kinetic energy of the wind in the wind is into mechanical power. This mechanical power is converted by generator into electric power, electric energy. This is the main principle of wind turbine. And various parts of the wind turbine. Here in wind turbine there is a main parts: blades, rotor, pitch system, low speed shaft, brake, gearbox and high speed shaft, generator, controller, anemometer, wind vane, yaw drive. These are the 12 different parts. Here in this diagram, blades, 3 blade system is there. Here is a rotor is connected to the end of the blade system, and here lower speed shaft is connected to the gearbox, and the gearbox is connected to a generator. Generator is here is a speed controller is there, and anemometer is connected. Anemometer is used to measure the wind energy, wind speed, different speeds, and these wind waves, and a natural law is connected in here. High speed shaft is connected to this generator, and this is connected a yaw drive, and this yaw drive is moving using a yaw motor, YAW yaw motor, and this why wind turbine is connected to the main pillar of this wind turbine. Here is a very high height pillar is connected, arranged. So in this arrangement, inner parts of the different parts of the this generator is converted this wind energy into electric energy. This is the simple mechanism of blades and rotor gives us the turbine. Turbine is built with the blades and rotor. In this rotor, shaft, gearbox, generator, these are the main parts, and there are the so many small parts are arranged in this turbine. And what is the various anemometer? Anemometer measures the wind speed and transmits wind speed data to the controller. This anemometer measure the wind speed, and this transmits to the controller. And blades lifts and rotates when wind is blown over them and causing the rotor to spin. These blades are used to rotate. Wind is blown over them and causing rotor to spin. Brake. This brake is used to stop the rotor mechanically, electrically or hydraulically in emergencies. Brake is used in emergencies. If there is any emergency, we are using brake. In normal conditions, there is no need of brake. And controller. Controller starts up the machine as wind speeds of about 8 to 60 miles per hour mph or roughly 12 to 24 kilometer per hour, and shuts off the machine at about 55 mile per hour. This means the maximum speed is of the blades is 55 mile per hour. That means roughly 75 to 80 kilometer per hour. The control is automatically used to stop the machine. It is the controller used to start up the machine and automatically stop the machine when high wind speed. And gearbox. Gearbox is connected the low speed shaft to the high speed shaft and increase the rotational speeds from the about 30 to 16 rotations per minute. That means up to 1 rotation per second to about 1000 to 1800 RPM, rotations per minute. This is the rotational speed required by the most generators to produce electricity, and the gearbox is used to rotate the and maintain the certain speed. And generator produce 60 cycle AC electricity. It is usually an off the shelf induction generator. Generator is used to generate the wind energy into electric energy. And high speed shaft, it drives the generator. High speed shaft is connected to the generator, so it drives the generator, and the generator is moving using this high speed shaft. And low speed shaft is turns the low speed shaft at about up to 1 rotation per second. That means 30 to 60 rotations per minute. Nozzle. Nozzle is used to sit up atop the tower and contains the gearbox, low and high speed shafts, generators, controller and brake. This total unit is known as nozzle. And here pitch turns blades out of the wind to control the rotor speed and to keep the rotor from timing in winds that are too high or too low to produce electricity. And blades and hub to generate together from the rotor. Next one is rotor. Rotor is connected to blades and hub together from the form the rotor. And the tower made from tubular steel or concrete or steel lattice supports the structure of the turbine. This tower is constructed with the concrete or steel lattice generally, and it supports the structure of the turbine. That means this base is tower is most sturdy. And wind direction determines the design of the turbine. Upwind turbines like the one shown here face into the wind, while downwind turbines face away. upwind turbines like the one shown here in diagram, and downwind turbines face away. There are different directions of the wind. Is due to the wind direction, these turbines are also arranged in different directions. And wind vane measures the wind direction and communicates with the yaw drive to orient the turbine properly with respect to the wind. With respect to the wind direction, turbine is moving. This wind vane is used to measure the wind direction. And yaw drive orients the upwind turbines to keep them facing the wind when the wind direction changes. And downwind turbines don't require a yaw drive because the wind manually blows the rotor away from it. And yaw motor powers this yaw drive. So yaw drives are used in upwind direction only. Downwind directions, there is no need of yaw drive. And working of wind turbine. Here, wind blows towards the turbine's rotor blades. The rotors spin around, capturing some of the kinetic energy from the wind and turning the central drive shaft that supports them. And in most large modern turbines, the rotor blades cannot swivel on the hub at the front, so they meet the wind at the best angle or pitch for harvesting energy. This is called the pitch control mechanism. Here we are using pitch control mechanism in the modern rotors, modern turbines. So in large modern turbines, the rotor blades can swivel on the hub at the front. They meet the wind at the best angle. And inside the nacelle, the gearbox converts the low speed rotation of the drive shaft into high speed rotation fast enough to drive the generator efficiently. And the entire top part of the turbine, the rotor and nacelle, can be rotated by a yaw motor mounted between the nacelle and the tower. So it faces directly into the oncoming wind and captures the maximum amount of energy. This wind turbine captures maximum amount of energy to convert the wind energy into electrical energy. And if it is too windy or turbulent, brakes are applied to stop the rotors from the turning for safety reasons. For safety reasons, where wind is very high speed wind or too widely or turbulent in cyclone time, the wind is more turbulent, so the brakes system is on, and for safety system brakes are applied the rotor to turning from the turning. That is, speed of the shaft is controlled by this brake when wind is turbulent. The electric current produced by the generator flows through a cable running down through the inside of the turbine tower. A electric cable is running down from the base area to this tower, and the electric current is produced by the generator flows through a cable running down to the base area through the inside of the turbine tower. A step-up transformer converts the electricity to the about 50 times higher voltage, so it can be transmitted electricity to the power grid or nearby buildings or communities. If the electricity is flowing to the grid, it is converted to an even higher voltage, 1,30,000 volts or more, by a substation nearby, which services many turbines. There are many turbines. Due to these many turbines, the electricity is more. This more electricity is connected to a electric substation. This substation is convert the electricity to about 50 times higher voltage, so it can be transmitted efficiently to the power grid. And homes enjoy clean green energy. The turbine has produces no greenhouse gas emissions or pollution as it operates. So we get we get a very green energy. So there is no pollution or there is no greenhouse gases. And setup types. Here the setup types are two types: not connected to a power grid and power created to a directly channel into powered site. And utility power grid stores the energy, connections must be available. And third one, combined warehouse photovoltaic solar cell system, as solar cells mounted on it, and solar cells thin wafers of the silicon which when exposed to the sunlight produces the electric current. There are three types setups. One is a simple system, it is not connected to the power grid, and power is created is directly channeled to the into produced powered site. And the second one is the utility of power grid, generally used in our country. It is connected to this electricity, generated electricity is connected to the power grid and supplied to the communities and business purposes, industrial purposes. And this stored utility power grid stores energy and connections must be available. And third one is the solar system connected. And harvesting maximum energy. The longer the rotor blades, the more energy they can capture from the wind. The giant blades, typically 70 meters to or 230 feet in diameter, which is about 30 times the wingspan or eagle. Multiply the wind force. So a gentle breeze is often enough to make the blade turn around. Put a turbine's rotor blades high in the air, they capture considerably more wind energy than they would lower down, and more hub height from the ground empowers the rotor to practice high velocity of air. And typical wind turbines stand idle about 14% of the time, and most of the time they don't generate maximum power. This is not a drawback, however, but a deliberate feature of their design that allows them to work very efficiently in ever changing winds. This is the harvesting maximum energy using these wind turbines. Here is different types of designs of the wind turbines is connected to the grid. The wind direction, there are different 1, 2, 3, 4, 5, 6 turbines are arranged in different directions and different sizes of the blades and wind turbines. Due to these height differences, these turbines catch the wind at higher levels of the atmosphere and lower levels of the atmosphere. One is the 200 meter head, and another one 2000, 2500, 4000, 7300, and here is a normal 3200, and height is 100 meters, 100 feet, and 200 feet, 300 feet, 400 feet, same like that height. And how to this wind power is stored? This is storage of the wind power. The one tried and tested possibility is pumped storage. Low price electricity is used to pump huge amounts of water up a mountain to a high level lake, ready to be drained back to the mountain through the hydroelectric turbine at the time of high demand when electricity is more variable. The large scale of wind power is storage here using this pumping huge amounts of energy. What are the advantages of this wind power? Wind turbines. The wind energy, very low carbon dioxide emissions, effectively zero once constructed, no air or water pollution, no environmental impacts from the mining or drilling, completely sustainable, unlike fossil fuels, wind will never run out, and turbines work almost anywhere in the world where it's reliably windy, unlike fossil fuel deposits that are concentrated only in certain regions. And unlike fossil fuel power, wind energy operating costs are predictably years in advance and very low costs, freedom from energy prices and political viability of oil and gas suppliers from the other countries. Now we are suffering with the hike of the oil prices, and due to this oil price hikes, we criticize our political parties. So there is no need of political viability or oil or gas prices are increased. It is a very freedom from these new jobs in construction, operation and manufacture of turbines. So new jobs are created using this generation system, construction system and operation system. And here is some disadvantages. Here is initial cost is very high upfront cost. The construction of wind turbines is a very cost compared to the remaining sources, and the extra cost and complexity of balancing variable wind power with the other forms of power, and extra costs of upgrading the power grid and the transmission lines through the whole system often benefits and damage local wildlife. These are due to these wind turbines, the local wildlife is damages, and a large overall land take through at least 95% of wind farm land can still be used for farming, and offshore turbines can be built at sea. Can't supply 100% of a country's power all year round, the way fossil fuels, nuclear and hydroelectric and biomass power, it cannot supply 100% of a country's power all over the year. And loss of jobs for people working in the mining and drilling. Due to this fossil fuels, we are mining and drilling, so many jobs are available in mining and drilling in fossil fuels. Here, due to this wind power, wind turbines, these jobs are lost that jobs. And finally, what is the wind power in India? The development of wind power in India began in 1986 with first wind farms being set up in coastal areas of Maharashtra, Ratnagiri and Gujarat and Waka, and Tamil Nadu, Tuticorin with 55 kilowatt Vestas and wind turbines. These are the first wind projects. So now Gujarat is operating with the almost all wind energy. There is no need of fossil fuels in Gujarat, and solar power. And these demonstration projects were supported by the Ministry of New and Renewable Energy. And as the 31st July 2006, the installed capacity of wind power in India is 27,441.15 megawatt with south, west and north area including the major part. The wind power generation capacity in India is 49,130 megawatt as per the official estimation in Indian Wind Atlas 2010. And this as a renewable energy has made target to produce capacity 60,000 megawatt till 2022. So, National Institute of Wind Energy has been established in Chennai in the year 1998 by the Ministry of New and Renewable Energy and Government of India. And it is knowledge-based institutions. These are this board. And the conclusions: energy demand across the world, including and developing countries like India, has led to deposit of fossil fuel, which although provides energy in enormous quantity, but affect the environment. Hence, to protect the environment from the hazards, other sources including wind energy is used. It has proved to compensate for energy very well. And the future looks bright for wind energy because technology is becoming more advanced and windmills are becoming more effective. This wind energy is rapidly increasing with the passage of time. Government as well as world is putting effort to understand its importance and bringing best out of it. Government implementing policies to harness it to recompense the hike in energy demand. So government is increases this windmills, and government is very favorably to generate electric energy using this wind energy. Thank you very much.